Okay, so get ready, because today we are going deep, like really deep, into the James Webb Space Telescope. All those fascinating articles you sent in, we're going to unpack them all.
Awesome.
And yeah, I know what you're thinking. Oh, great, more space pictures. But trust me, this goes way beyond pretty pictures. We're talking about, like, the universe's baby pictures. It's like a time machine.
Yeah, it really is. It's letting us look back billions of years to when the first stars and galaxies were, well, just babies themselves.
Exactly. So let's jump right in. One of these articles, it talked about this massive gold-plated mirror. What's the deal with that? Why gold?
Well, gold, it's always been the symbol of luxury, right? But
Yeah.
in space, it's actually incredibly useful for reflecting infrared light. So the JWST's primary mirror, it's a giant, 6.5 meters across, made up of these 18 hexagonal segments, all coated in gold. And that gold coating, that's what lets it capture those super faint infrared signals, the ones from the farthest reaches of the universe.
Okay, so gold is key for capturing the infrared. But why is infrared light so important? One of the articles mentioned seeing the universe's infancy, which sounds pretty wild. How does infrared help us see back in time?
All right, so imagine an ambulance coming towards you, sirens blaring. As it gets closer, the siren sounds higher, right? And then as it speeds away, the pitch drops. It's the Doppler effect. And it happens with light, too.
Oh, so just like those sound waves from the siren, light waves can stretch and compress depending on if something is moving towards or away from us.
Exactly. And because the universe is expanding, the light from those faraway galaxies, it gets stretched, shifted towards longer wavelengths. And that's where infrared comes in. The JWST is designed specifically to see this stretched light, the stuff from way back when, further and older than any other telescope we've ever built.
Wow. Okay, so it's like the JWST is this giant, super sensitive infrared eye. It can see stuff that's invisible to our regular telescopes. Is that right?
You got it. And there's another key piece here, the sun shield. One article mentioned it's the size of a tennis court. Why do they need something that massive just to block out the sun?
Well, if it's trying to detect these incredibly faint signals from billions of years ago, I'm guessing any heat from the sun would just completely mess up the readings.
Hmm.
Like, I don't know, static on a radio.
You're exactly right. The sun shield keeps the telescope super cold, like close to absolute zero. You see, heat creates its own infrared radiation, and that would drown out those faint signals the JWST is trying to pick up. It's like trying to hear a whisper in a noisy room. You got to block all that extra sound out.
That makes sense. So we've got this incredibly complex gold-plated super cold telescope designed to catch these whispers of infrared light from billions of years ago. And one article you sent in to talk about how the JWST is looking for the very first galaxies that formed after the Big Bang. I mean, did they actually find anything?
Oh, they found something, all right. And it's totally changing how we think about how galaxies are born and grow.
Okay, hit me with it.
So, picture the universe as a newborn baby, just a few 100 million years old. That's what the JWST is looking at. And guess what? These early galaxies aren't those, majestic spirals we're used to seeing. They're smaller, more irregular, kind of chaotic.
So those perfect spiral galaxies we see in, like, Hubble images, that's not how they started out at all. It's like we're seeing the messy, chaotic beginnings of something that eventually will become beautiful and complex.
Exactly. It's like watching the universe evolve right before our eyes.
This is amazing. You also sent in something about how the JWST is studying exoplanets, those planets orbiting stars other than our sun. Can it really tell us what the atmosphere of a planet light years away is made of? I mean, how's that even possible?
It does sound like sci-fi, right? But it's totally real. Now, it can't just snap a photo of an exoplanet's atmosphere. They're way too far away. But here's the thing. When a planet passes in front of its star, some of the starlight goes through the planet's atmosphere, and that starlight, it carries clues about what's in that atmosphere.
Wait, so the starlight changes when it passes through the atmosphere, and the JWST can detect those changes. I'm trying to picture this. Is it kind of like how a prism splits white light into all the colors of the rainbow?
That's a great way to think about it. It's called spectroscopy, and it's like decoding starlight to see what's in it. And guess what they found in the atmosphere of a super-Earth over 100 light years away?
Okay, let me guess. A super-Earth, that's a rocky planet, but bigger than Earth, right? So maybe got oxygen or methane. Those are signs of potential life, aren't they?
You're on the right track. But in this case, they found something even more basic. Water vapor.
Water. Wow, a planet with water in its atmosphere. 100 light years away? Does that mean it could be habitable? Could there be life swimming around in alien oceans on this super Earth?
It's definitely possible. Now, water vapor doesn't automatically mean life, you got to consider other things like temperature, pressure. But it's a pretty exciting clue, right? Suggests that this distant world might have the right conditions for life as we know it.
This is getting more and more incredible. It's like each new discovery is opening up a whole new world of possibilities.
Speaking of new worlds, you also sent in an article about black holes. Those super dense things, not even light can escape them. So how can the JWST even see a black hole?
That's the thing. It doesn't see the black hole itself. It sees the effects it has on everything around it. Like, imagine a cosmic drain, right?
Hmm.
Swirling water down. You can't see the drain itself, but you could see the water swirling around it.
Gotcha. So the JWST can see the stuff swirling around a black hole. What kind of stuff are we talking about? And what's it telling us about these mysterious objects?
So black holes, they're surrounded by these disks of superheated gas and dust. And as this stuff falls in, it emits this incredibly bright light, including infrared. And the JWST can see this light in amazing detail. It's showing us how black holes interact with all the stuff around them. Like watching a cosmic ballet, with the black hole leading the dance. A cosmic ballet, I love that. So by studying this swirling material, the JWST can tell us about the black hole itself. Is it helping us understand how they form, what role they play in the universe?
Exactly. It's giving us this incredible detail about how black holes grow, how they change galaxies, even clues about how they formed way back in the early universe. It's like the JWST is piecing together the puzzle of these enigmatic objects, revealing secrets that have been hidden for billions of years.
That's also fascinating, but honestly, I'm also blown away by just how beautiful the pictures are. Remember that one of the Carina Nebula? It looked like a cosmic cliffside.
Oh, yeah.
Or that one of Stephan's quintet, those 5 galaxies all tangle up in this gravitational dance. They're breathtaking.
They really are. And the best part, those images aren't just pretty pictures. They're packed with scientific data, giving us more insights into the universe than ever before. Every pixel tells a story, revealing the secrets of star birth, galaxy evolution, the laws of physics.
It's like we're looking through a window right into the heart of the universe, seeing things that no human has ever seen before.
Exactly. And this is just the beginning. The JWST is going to be working for at least another decade.
Yeah.
Who knows what other incredible discoveries are waiting for us out there?
This is starting to feel like more than a deep dive. It's like we're on this cosmic roller coaster ride.
Haha. Yeah, you're not wrong. And we've only just barely scratched the surface of what the JWST can do. But maybe we should take a breather for a second. Let all this sink in. What stands out to you the most so far? What are you most excited about?
Yeah, it's really a wild ride, isn't it? And we have covered a lot.
I know, it's hard to pick just one thing, but honestly, the idea that we can now analyze the atmosphere of a planet that's 100 light years away, that just blows my mind.
It really shows you how far we've come.
Right.
In understanding the universe, I mean.
Yeah, absolutely. Speaking of how far we've come, one of the articles talked about, the global team behind the JWST. NASA, the European Space Agency, the Canadian Space Agency, all working together. Right. You don't see that level of cooperation every day, especially on something this huge and complex. I mean, building the most powerful space telescope ever, that takes a village, a global village.
Exactly. It shows what we can achieve when we all work together, even if it takes decades of planning.
Yeah, it's a win for all humankind, for sure, not just for science.
Speaking of wins, the articles mentioned that JWST should be operating for at least another decade. What are you most excited to see in the years to come? What mysteries are you hoping they'll crack?
Oh man, so many possibilities. We might be able to see even further back in time, maybe even closer to the Big Bang itself. And who knows? We might find entire new groups of exoplanets we didn't even know existed, maybe even some with signs of life.
Hold on, signs of life. Are we talking about actually finding aliens?
Okay, let's not get ahead of ourselves. But it's not totally impossible, right? The JWST, it's powerful enough to detect, what they call biosignatures, chemical fingerprints that could mean there's life on other planets.
Now, that would be the biggest news story of the century. But even if we don't find, E.T. phoning home, just knowing that we're closer to figuring out if we're alone in the universe, that's pretty amazing in itself.
You're telling me. And even beyond those, headline-grabbing discoveries, I'm really excited about how the JWST will keep refining our understanding of physics, how stars and galaxies change over time, all that stuff. The really fundamental things about the cosmos.
It's like we have this incredible tool, and we're just figuring out how to use it.
Exactly. And that's what's so great about it, right? It's the unknown that drives us to explore. It's those questions we haven't even thought to ask yet that the JWST might be able to answer, like opening a door to a whole new universe of possibilities.
It really is inspiring. But I do have to wonder, for the average person out there, someone who's not a scientist or an astronomer, how can they connect with all this? How can they share in the excitement of these discoveries?
That's a really good point. And luckily, the team behind the JWST has done a fantastic job making their work accessible. Releasing those stunning images, making videos, even chatting with folks on social media.
Oh yeah, their Instagram is amazing. Just those pictures alone, they could inspire a whole new generation of scientists and explorers.
You're absolutely right. And, even beyond the visuals, there's something really powerful about knowing that we humans on this little planet built a machine that can look back billions of years and actually see the birth of stars and galaxies. It's a reminder that we're part of something so much bigger than ourselves.
It really does give you chills, doesn't it? It's a reminder that there's just so much more out there than our daily lives, so much more to discover and understand.
It makes you wonder what else is out there, what other mysteries are just waiting to be found.
Exactly. And with the JWST, we might actually be able to find out. But I do have one more question for you. It's a bit more philosophical, I guess, maybe even a little existential.
Oh, I'm intrigued. Tell me.
It's just that thinking about the vastness of the universe, all those billions of galaxies, the potential for other life out there, it makes you feel kind of small, doesn't it?
Yeah.
Like our little planet and all our problems, they just seem tiny.
I know what you mean. It's definitely humbling, but you know what? It can also be empowering.
Empowering. How so?
Think about it. We, humans, on this tiny little planet, we built something that lets us look back to the beginning of time. We can study the very essence of reality. That's pretty amazing if you ask me.
You're right. It shows what we're capable of. Our ingenuity, our curiosity, our drive to explore the universe around us.
Exactly. It's proof that we can do amazing things. We can push past our limits and keep learning more and more about the cosmos.
It really is like we're part of this grand cosmic story, one that's been going on for billions of years.
And the JWST, it's helping us write the next chapter.
So as we wrap up our deep dive into the James Webb Space Telescope, and all this incredible information you sent in, what's the one thing you hope our listener walks away with?
For me, it's not just about the science. As amazing as all the discoveries are, it's more about realizing that the James Webb, it's for everyone.
I know. Yeah.
It's the symbol of how curious we are as humans, our ingenuity, and what we can achieve when we all work together.
It's like that feeling you get when you look up at the night sky, all those stars. You realize just how vast and mysterious everything is. But instead of feeling small, you feel the sense of awe, of wonder.
Exactly. And I hope that feeling sticks with our listeners, long after they're done listening to us. It's a reminder to keep asking questions, to never stop exploring, and to always hold on to that sense of amazement about the universe around us.
I love that. And as we sign off today, I want to leave our listeners with something to think about. We've talked about all the amazing things that JWST has already done, but it's going to be up there for at least another 10 years. What else might we find? What other mysteries might it help us solve?
Oh, man. It's a pretty exciting time to be alive, right? We're living in this age of incredible discoveries, and the James Webb is right there at the forefront. Who knows what the future holds? Maybe we'll find proof of alien life out there. Or maybe we'll unlock the secrets of dark matter and dark energy. Or maybe we'll stumble upon something so strange, so unexpected, that it changes everything we thought we knew about the universe.
The possibilities really are endless. And for one, I can't wait to see what comes next. Thanks for taking this deep dive with us. Keep looking up, everyone, and never stop exploring.